Greetings, welcome to elementary mathematics. So today we're going to deal with differentiation. So you'll forgive me. On your left side, you have questions there which are a bit blurry, but it's okay. And then on your right, that's where we'll be doing our workings. So the first question, we need to find the dy over dx given y being equals to u cubed minus u squared plus u plus 1, and u equals to x cube plus 1. So we need to find dy over dx, but we have y in terms of u and we have u in terms of x there. So what we can do here is to introduce the u on dy and dx, so you can have something of this kind by so that we'll be able to apply the chain rule. So you can have dy over dx being equals to what? Dy over du times du over dx. This is simply the same thing as dy over dx because eventually du and du will cancel out. So we haven't changed much on dy over dx. So that's basically what we are looking for. So now let's first find dy over du. So your dy over du in this case is just going to be what? It's just going to be you apply the exponential rule wherein you bring the exponent down. It's gonna be 3u, and then you minus 1 from what? From the exponent, which is gonna be 2. So it's gonna be 3u 2, and then you bring the exponent down again. It's gonna be negative 2, and then u, and then 2 minus 1 is just 1, and then the derivative of u is just also gonna be you bring 1 down and then you minus 1 from the exponent, which is just going to be u to the power of 0, and u to the power of 0 is just 1, and 1 times 1 will just give you 1. So you also check the derivative of 1. So the derivative of that 1 is just going to be what? 1. It's just going to be 0 because we're deriving what? A constant. The derivative of a constant is 0. So now let's continue and find our du over dx. So this is what we're derivating u with respect to x, and then on dy over du we're derivating y with respect to u. So when this means that we focus on deriving u with respect to x. So our u is what? Is x cubed plus 1. So this means when we derive our u is gonna be what? 3x squared, and then the derivative of a constant is just what? It's just 0. So remember our dy over dx is dy over du times du over dx. This means now our dy over dx will just be equals to 3u squared minus 2u plus 1 multiplied by 3x squared. So what we have here, let's just we'll have to remember our u. Now we know our u, that is x cubed plus 1. We will substitute our u here so that we can have the same variable throughout. So this means we're gonna have our 3x squared outside here, and then we'll have to substitute our what? Our 3x cubed plus 1 to the u. When we see u, we put 3x. No, not 3x cubed. We put x cubed plus 1. We put x. Our u is x cubed plus 1, and then you minus 2 into x cubed plus 1, and then you add your 1, and then that's it. You continue with it. So it's gonna be 3x squared, and then you work on what is inside the brackets there. So what you have there is oh, we forgot the squared. here. So what we have inside is your 3 there into, when we square this, when we have 3 cube plus 1 multiplied by 3 by x 3 plus 1, this gives us x3 times x3 is just x6, x3 times 1 is just x3, and then x3 times 1 is just x3. This means you're gonna have 2x3, and then 1 times 1 is just 1. So this is what you're gonna have right here on x6 plus 2x3 plus 1 minus our 2 uh, into x cube plus 1 plus 1, right? We also continue with it, simplifying it further. So this is what we have, 3x squared into what? Now we will multiply our 3 throughout. This means you're just gonna have a 3x6 plus 3 times 2 gives you 6x3, 3 times 1 plus 3. So um, to continue with it, we'll subtract what? 2x3 minus 2 plus 1 plus 1, right? So continuing further with it, we say that okay, now we have something there. What we have 3x to the power of 6. Okay, what can we do with it? We can just relax with it, but we have like terms now, 6x cubed minus 2x cubed, and then we have 3 minus 2 and 1. So how can we deal with that? Now let's just put our 3 squared here, and then we're gonna have 3x6, and then 6 minus 2, simply 4x cubed, and then 3 minus 2 is 1, 1 plus 1 is 2, and then 2. So this will be your dy over dx. You can take it further, or you can also leave it here. It's fine. So let's look at 5.1a. So 5.1 5.1a. So it says we find the derivative if you have y equals to x into 3, x minus 2 into x 4 minus 1, right? So before we can derive it, let's try and see if we can put the equation in a good manner that will allow us to work with it. So this is what you're going to do here. This is the same, and let's say we have 2 into 4 into 6. So this is the same as 2 times 4 giving you what? 8. And then you multiply 8 by what? By 6. And then you continue with it. So in this case, this is just going to be what? X times 3x minus 2 is just going to be 3x squared minus 2x, and then x 4 minus 1. And then you continue with it there. So we see that okay, we can still go on about it before we can derive it. So now 3x squared times x to the power of 4, this is the same as 3x 3x 6, and then 3x squared times minus 1 is just minus 3x squared. And then you have minus 2x times x minus x to the power 4, that is minus 2x 5. And then you have number 2, you have negative 2x times negative 1, which is just going to be plus 2x. So now we can derivate what we have here. So let us first rearrange it in a proper manner. Minus 2x5 minus 3x squared plus 2x. And then now we can do what? We can derive y with respect to x. This is the same as y prime, which is same as so this is gonna give us 6 times 3. It's just gonna be 18 x to the power 5 minus 10 x to the power 4 minus 6 x plus 2. So when you derive 2x, it's just you take out the constant outside, and then you derive the what? Derive the x. So that is just gonna be your 2 times 1, because the derivative of x is 1. So 2 times 1 is just gonna give you what? 2. So yes, that is just how it is. And then now let's look at that is your final answer there. Now let's look at your B. So for B we have f at t being equals to 2t squared minus 3t over t cubed. So you might assume that you're gonna use quotient rule here, but that is not the case, because you use quotient rule if you have a function underneath and a function above. These are some of the rules of quotient rule. So you use quotient rule if you have a function above as perhaps g at x, and also if you have a function below, But in this case, we do not have our function above and a function below. We just have our t. A t there is can be a number, it can be a constant. So now let's try and see if we can simplify what we have here before we derive it. So now 2t squared minus 3t over t cubed is the same as 2t squared over t cubed minus 3t over t cubed, right? So this gives us what? It gives us 2t squared divided by t cubed is the same as let me write it this way for your understanding. It's the same as 2t squared times t to the power of negative 3. So when you add 2 with negative 3, it gives you negative 1. So also this side is the same as 3t times t to the power of 3, negative 3. So this is the same as 2t to the power of negative 1 minus 3t to the power of negative 2. So now if it's like this, we can now find what our f prime at t. We can find our f prime at t. So this is just what you bring the exponent down, you keep the constant outside, and then you derive your t there. So it's just you bring the exponent down and then you minus 1 from the exponent, which is just going to be -2, and then you subtract what the constant, you keep it outside, and then you bring the -2 down, and then you subtract 1 from what, from the exponent, which is just going to be -3. So that is how it is, and then you continue to simplify it. So 2 times -1 is obviously -2t to the power of -2 minus minus 3 times -2 is plus 6t to the power of -3, right? So what we did here was just to apply the power rule. So now as we continue with it, we shouldn't leave our exponent as negatives, so we should try and write them as positives. So this is what you can have: -2 over t to the power of 2, right? Plus what? Plus 6 divided by t to the power of 3. So you can leave it this way, or you can further write it as equals to divided by the common denominator between the lowest common denominator between t squared and t cubed is just t cubed, right? So, and you're gonna have above there, you're gonna have plus 6 and negative 2t. So how do you arrive on this? To arrive on that, remember we have -2t squared plus 6 over t cubed, right? So this is the same as what? Multiplying what is underneath, you have t squared into t cubed, right? And then you also have what? Because multiplied, you have -2t 3 plus 6t squared. That's what you have. And then you continue with it. We see that, okay, we can have the common factor in the numerator, which is just gonna be what? T squared. So we're gonna have -2t plus 6 divided by what? T squared times t3. So t squared is gonna cancel with t squared, and you'll be left with -2t plus 6 over t cubed. So that is the final answer there. So that's how we arrive to it. So to continue, we have our C. So for C, we have g at x being equals to the cube root of what? Of 1 over 5 x 5 minus 11x. So this one might tend to be a bit challenging, but let's continue with it and apply the appropriate rules. So let's rewrite it in a proper manner. To rewrite this, you can just write it in, yeah, you can just write x5 over 5 minus 11x all to the power of 1 over 3. So that is what we can have there, which is gonna help us to work easily on it. So you can just say x5 over 5 minus 11x. So we eliminate the square root there so that we'll be able to work with what? With the function. So what we have here, if you can check, let's go to our rules. So this is your what? This is still your g at x. So we have something of g at x equals to h at x to the power of what? 1 over 3. So the rule that is appropriate to apply here is the chain rule. So we basically have uh, G at we basically have something of this kind. G at so y is equal to G at h at x, like that. So that is just how you have to apply your chain rule. So chain rule says what? You derive the whole function. You derive the whole function that you have there, and then you multiply by the derivative of the function inside it. So in this case, this means that since I said that we have something of this kind, you have something of this g at x equals to h at x 1 over 3, something of this kind. So this means what we're going to do here is you will find your g prime at x, which is just going to be 1 over 3, and then you still have your h at x there, right? And then you minus 1 from what? From the 1 over 3. And then what you do, you multiply by the derivative of the inside, which is just going to be h prime at x. That's how you apply, that's how you deal with functions of this kind. You apply this if you see that you have a function inside a function. That's why you get to apply the chain rule. So now let's see how we're gonna apply this. So this is how it's gonna go. So you're gonna have okay, like we said, we bring the exponent down 1 over 3, and then we write what we have, 5 minus 11 x, and then 1 over 3 minus 1 is just negative 2 over 3. Then we multiply by the derivative of the inside. The derivative of the inside is simply what? Is simply 1 over 5x to the power of 5 minus 11x, which is the same as 5. You take 1 over 5 out, and then you multiply it by 5, and then x to the power of 4. Then multiply by, you take 11 out, and then you multiply it by derivative of x, which is just gonna be 1. So 11 times 1 is just gonna be 11, and then 1 over 5 times 5 is just 1, so you're gonna be left with x to the power of 4 minus 11. So that would be your what? Your answer there. Remember, what we did here, what we wrote here now is what? Is g prime at x. It's no longer g at x, but it's g prime at x. So you must be able to write, you must write it in a proper manner there. So now we can further write our g prime at x in a proper way without negative exponents. So how are you gonna do that? So we see that okay, we have 1 over 3 something. So obviously the 3 is telling us that is underneath, and then we have negative exponent. This tells us that also this comes where? Underneath, or in the denominator, minus 11x power of 2 over 3. You can also introduce a square root here if you like, or a cube root if you like. So and then we multiply by what? By x, 4 minus 11. This is the same as multiplying 1, which is the numerator, multiplying 1 times what? times x to the power of 4 minus 11. So that is just going to be x to the power of 4 minus 11. So this will be your final answer. So moving on, you also have the last question there, which speaks about the lean. This can also be a bit challenging, but if you give it practice, you will understand it much better. So let's check D, which says, what does it say? Oh, our D is here. So it says h at x is your lean e to the power of x times sine 2x. So now here, um, remember, let's go to the rules again. So the rules are here. We have the derivative of what? The derivative of, if your y is equal to e to the power of x, then the derivative of e to the power of x is just e to the power of x. And if you can check inside the ln there, we have something of this kind. If you can check, we have something of h at x, which is just our y, is equals to what? Ln into f at x, right? We have a function inside the ln there. This means we're gonna use what? We're gonna use this ln function to do what? To deal with that question. Although there are other methods, but the easiest way and the simpler one is to use this ln function. So to also continue with this one, you must look how your f at x is. So in this case, your f at x, which is just e x times sine 2x. If you check it, you have two functions there. The function of e to the power of x multiplying with another function. So it's the same as having h at x times g at x with e to the power of x being your h at x and your sine 2x being your g at x. So this means here, if we have something of this kind and we want to derive it, we're gonna need what? We're gonna need to apply the product rule, which is this rule. So the product rule says what? Says that if you have two functions that are multiplying each other, to find the derivative of them, you keep one and you derive the other, and then you add. After adding, you derive the one that you kept previously, and then you keep the one that you derived previously. I'm gonna apply it and you're gonna see. So now I'm gonna wrap what I just wrote here into us just for your understanding. So this is what we're gonna have now. We're gonna have uh, we just apply the okay, this is just gonna be h prime and x. It's equals to what? H prime and x is gonna be d dx. It's gonna be e x times sine 2x. This is your f at x, right? And then we derive in the numerator, we derive the what? That f at x of ours. Now, how do we derive it? Now, to derive this, you have to do what? You have to find d dx of what? Of e to the power of x, right? And then multiply it with what? With sine 2x, and then add the what? The e to the power of x, right? And multiply it with what? With the dx of what? Of sine 2x. So that's what you need to do. Okay, to continue, the derivative of e to the power of x is just e to the power of x. This is what we learned from the rules. And then we'll multiply by our sine 2x, right? And then we add our ex, because here we're just keeping it as it is. Here on the numerator, we apply the product rule. We derive one, we keep one, and then with the one that we derived first, we keep it after the plus sign, and then we derive the one that we kept previously. So this means that now you're gonna have ex times sine 2x plus e to the power of x times the derivative of sine 2x. Now let's look at sine 2x as well. Let's look at sine of 2x. So this is also a function in a function. This is also a function in a function. You can just keep in mind that, okay, when you derive the derivative of sine 2x is actually 2 cos 2x. This is the derivative of sine 2x. So, and the derivative of sine x is just, I think it's just, the derivative of sine x is just cos x. So now, let's look into it, how we arrive at 2 cos 2x. So, we need to derive what? Derive our sine 2x. So, we have this, we have derive what? This sine, and also derive what? This 2x. Let's just say this is the sine of what? Let's assume 2x is just a. So you must derive the what? The sine, the function, and also derive the what? The a. So this means we're gonna have something of this kind. Let's say you have dx of f at a, right, which will just give rise to the dA times f at a multiplied by d x of what? Of a. Remember, your a in this case is a function. So, or we can just replace our a and say, maybe let's say it's g. Have a g, dg, a g, right? So this means that what we have here is just gonna be dg of what? Of sine at what? At g, right? Multiplying by what? By dx of what? Of g. Remember, what is the g? The g is just 2x, right? So this means that, okay, the sine of g is the same as what? That's the cos. Derivative of sine g, or derivative of sine x, is cos x. Derivative of sine g is just what? Cos g, times the derivative of 2x is just gonna be 2. So this means you have what? Cos, remember g is our g is 2x times 2. So this is the same as what? 2 cos into 2x. So now that is it. So we go back. We go back and continue with what we were doing up there. We found the derivative of sine 2x. You don't have to do your work in there. You just have to show it here. Okay, that the dx of sine 2x is what? Is times 2 cos 2x, and then you divide by your ex times sine 2x. So how this is what, okay, we can say that, okay, up there we have a common factor of e to the power of x, and then sine 2x plus 2 cos 2x, and then you divide by what, ex times sine 2x. So this cancels this one, then you'll be left with what? You'll be left with sine 2x divided by sine 2x is the same as what has remained cos 2x over sine 2x. So what do we have here? We only have 1 here. Sine 2x over sine 2x is just 1. So we add what? Okay, we can say that, okay, we have 2. But what is cos 2x over sine 2x? That is cot 2x. So your final answer is 1 plus cot 2x. So that's it for today. Thank you.